Hello coders, welcome to my video. So in this video we'll start with the introduction of the callbacks in C. So in a C programming language we usually call a function directly and get the result immediately. Okay. But in the real time system we don't always know when something will happen. So all the events maybe they are asynchronous rather than a synchronous. Okay. So that's why we need a callback to encounter certain scenarios that are asynchronous. So what is a callback in C? A callback in C is a function whose address has been passed to another function. For example, I have a function fn and I have integer a and integer b passed as an argument to this function. So for a callback to work, we need to pass the address of the function 1 to this function. At a certain event that is occurred, for example, E1, I am passing this. For event E2, maybe I am passing the address of function 2 to this same function. So that will give you a different result. Depending on the events, we are passing these functions to this base function. So this is before starting the callback. The basic of the callback is a function pointer. Okay. So first we have to understand what is a function pointer, and for that, what I will do, I'll create a function named add, and I'll return a plus b from this function. Okay, and input to be integer a comma integer b. I'm just adding it up and returning. Okay. So you have the address of this function as well, right? So I'll try to print it here. So let's printf the address of the add function, that should be percentage p, and here I'll put add, and I will print the address of the add function now. So every function have one address as well in the stack. So as we already know what is a pointer, pointer will store the address of some variables. So similarly, we have a pointer that will save the address of the function as well. Okay. So how to define that pointer? So we need to know the generic template of the pointer that is saving the address of this function add. So the first is the return type. So I should take the same return type as add. And now I have star. Then I have a name of the pointer, ptr add, or I'll take a generic ptr only. And now I have the arguments, for example, int star int. Two arguments are there, and this will give you a pointer that can be pointed to this function, and it will store the address of this function. So next is how to save the address of add in this pointer. Okay. So for that, we just need to map this ptr is equal to add, and I will print the address of ptr here to check if this address has been saved properly into the ptr. So address of PTR. Okay, and again, if I compile and execute, so here, if I see both the addresses are same. Okay, so now our pointer have the address of add. So now, how to run this function using PTR? As PTR already have the address of add function. So if I do PTR, I need to input some value. So one, or I'll take 4, comma 3, and I will print this. Print f output is percentage d, and I have this here. So the output should be 7. And if I compile and run it, I'll get a 7 value here. So in spite of using or calling the add function, like add 1 to 4 3, we are calling this PTR and getting the same result. So this is of no use. Okay, so obviously you're taking a pointer and just printing the same for the same function. So how it becomes a callback? That is our point. And how to convert this function pointer into a callback in a use case scenario. So what I will do here, I will take a new function 3yy, and I'll take this function name as subtract, and here a minus b is there. So now as I map the add here, I can map the subtract as well here, as we have the return type and the argument of same type. Okay, so after this, what I will do now, I put the pointer to subtract. Okay, and now I take the address. I'll put here the address of PTR, and now I need the output. So same output, PTR this one, output. Here I'll take subtract, and here I'll take add. Okay, and this is add function, and here I will take subtract function as well. So I need to get the output of subtract as well, because the same pointer is being used to point to two different functions at different point of time. So if I compile it and run it again, if you see here the subtract function, this is the address, and the same address is reflected here as well, even, and the value is 4 minus 3, that is 1. So the same pointer is pointing to two different functions at two different times. Okay, so this is how the function pointer is being utilized. So in spite of doing this, can I pass the function to another function? So I'll remove these all subtract and other things. And now I'll take a new function of the name int operate. Okay. So this will handle the functions. And here, if I take int a comma int b, and last one should be a function pointer, and it should be int star of fn and int comma int. And here, what I will do, fn a comma b, and return 1. Simple, nothing else. Okay, and what I will do here, I will take printf output is equal to percentage d, or what I will do here, I'll return this value, whatever comes from this function. So output add, we have operate, and here what I will do, I'll do 1 comma 2 comma, then we have the function pointer that should be add, and let's see first whether it will work or not. Okay, so if you see here, you will get a value 3 out of this. 1 and 2 is 3. Okay, so similarly I can do it for subtract as well, where I can take 6 minus 2, and here what I will do, subtract, and I should get a value as 4. So you see, add value is 3 and this is 4. Okay, so what I did here, I'm just passing the address of this function here, and subtract for here, and the values we are getting regarding these functions only. So as we are passing the address of the function to this function, so it behaves like a callback. But here we are only calling this function pointer, not the function. So we don't know what our function it comes here. I should operate on that function, whatever is passed here, and we'll get the result for operate. We can do for multiple functions as well here. So if I don't need this long function pointer here, so what I will do, I can also type def here. Okay, and here I'll take, for example, I'll take function ptr, and here, in spite of using the whole thing, I can take f and ptr and fn. Okay, so this way also it will work. So you see, same output. So this is how we work with basic callback and the function pointers. So if you have any query, just post a comment below. See you in the next video. Thanks.